Hello everyone. It is pleasure to be here. My name is Reiko Kamimura. I am a vice principal at a high school in Tokyo. I am also a member of the doctoral program at graduate school, majoring in science education. This research was conducted in collaboration with Professor Toriyabe at my previous high school. In addition, Professor Goto of Toyo University is also participating in the joint research. Today I am here to talk to you about our research. Guidance on finding problems systematically based on questions, research questions, and hypothesis. Research on teaching methods for setting assignments connecting junior high school and high school. We will start our presentation now. Here is the table of contents for today's presentation. The research presented this time was conducted on schools designated as super science high schools by the Ministry of Education, Culture, Sports, Science, and Technology in Japan. There are 4,874 high schools in Japan. Among them, there are 217 schools designated as super science high schools. At super science high school, students' research is actively conducted. But even in schools that are not designated as super science high schools, students' independent learning is emphasized, and an increasing number of schools are working on subject research. The Ministry of Education, Culture, Sports, Science, and Technology, MEXT, of Japan states that inquiry is important. Inquiry activities at the level where teachers give assignments and work on them are becoming widespread. But research at the level of identifying issues based on the questions students come up with and setting hypotheses is not conducted, especially in high schools. We thought that the process of identifying issues and setting hypotheses based on the questions felt by the students was sufficiently instructed. 4874-217. I'll start with talking about a domestic survey. In Japan, there is a need to improve the quality of learning, and in particular, the importance of incorporating inquiry-based activities is mentioned. Domestic surveys have revealed that there are problems in the implementation of inquiry-based activities in high schools. For example, in the teacher questionnaire survey on the basics of chemistry classes in the high school course of study implementation survey report conducted by the National Institute for Educational Policy Research, 36.9% of the respondents answered positively to the question, "Do you incorporate learning activities in which students make predictions based on their own ideas and then observe and experiment?" In addition, 13.6% of the respondents answered positively to the question, "Do students adopt a learning plan to plan observations and experiments based on their own ideas?" Because of these, the purpose of this study is to improve students' ability to identify issues. In order to achieve this goal, we considered a science and mathematics curriculum. It connects junior high school, and questions, research questions, and hypotheses are systematically arranged for the inquiry-based research in secondary schools. We also developed a student textbook with which teachers instruct students in setting issues. These curricula and textbooks were developed by us, the mathematics and science teachers. The figure on the left is an example of a text for the first grade of junior high school. I will talk characteristics of the practice of this study of this research. First, the curriculum systematically arranged guidance on questions, research questions, and hypotheses for the inquiry-based research in secondary schools. Questions are the awareness of problems that arise when something happens that is out of step with what you have experienced or expected. It is expressed by the interrogative word why. A research question is a more concrete version of a question and includes causative variables. It is expressed by the interrogative word what or how. A hypothesis is expressed in this way, from cause to effect, and so on. The cause is the independent variable, and the result is the dependent variable. Second, based on the annual plan, a course was established to learn specific methods for problem discovery, hypothesis, and verification plans necessary for issue-setting situations. Next, in order to make the learning content of junior high school and high school more systematic, content on questions, research questions, and hypotheses of learning in the issues finding scene was arranged. At last, in order to enable teachers who have no experience in teaching subject research to teach in the course, we developed textbooks that specifically indicate the contents of instruction and conducted in-school training to share information on teaching methods. In order for students to make plans for observations and experiments based on their own ideas, it is necessary for students to have a process of identifying issues on their own. However, previous studies have pointed out that high school students are inadequate in their ability to formulate hypotheses. Inagaki, 2015, reported that although research projects enable students to make positive efforts in experiments and presentations, they are insufficient in terms of students' issues with the discovery and hypothesis setting. Yamashina, 2020, points out that there are situations where the guidance of issue settings in high schools is left to the supervising teacher. Although, the guidance will be based on the experience of each teacher. Therefore, the purpose of this study is to improve students' ability to identify issues by devising and practicing a science and mathematics curriculum for systematic issue-setting situations that connects junior high school and high school. This table shows the types of problem-finding courses conducted from the first year of junior high school to the second year of high school. It also shows that the table systematically arranges questions, research questions, and hypotheses. A total of 705 students participated, including 308 students in grades 1 to 2 at public high schools, which are super science high schools in Tokyo, and 397 students in grades 1 to 3 of the attached junior high school. We practiced it on students from the first year of junior high school to the second year of high school for 1 year in the 2021 academic year. Previous studies on the conversion process from question to research questions include, for example, the study of Yoshida and Kawasaki, 2020, which pointed out that elementary school students lack knowledge about research questions formation and conversion into research questions. From this, we consider that the lack of knowledge to generate research questions from questions and to formulate hypotheses from research questions is a factor that makes it difficult to find problems even in high school students. Based on these previous studies, we decided to examine a curriculum that systematically arranges questions, research questions, and hypotheses on guidance regarding issue settings and subject research at integrated junior and senior high schools. In addition to examining the curriculum, we developed a textbook for teaching students to set issues as a specific way to instruct students and used the developed textbook to practice it for students from the first grade of junior high school to the second year of high school for 1 year. As shown in the figure here, from the first grade of junior high school to the second year of high school, the questions are arranged to that the research questions and hypotheses can be learned in a spiral and students can find research questions from questions and set hypotheses. 1-2. This is what a second-year junior high school student wrote in his reflection after research questions discovery course. This student writes that they want to discover the issues around them. And he wants to find various questions in the classroom, daily life, media, etc. This is what a second-year junior high school student wrote in his reflection after research plan course. This student write that he wants to formulate a hypothesis from their own questions. And he feel like he was able to come back to the first question. After the course, we conducted a questionnaire survey to the students to investigate whether they felt that their ability to identify issues had improved. The responses were based on the 5-point method: 5, improved; 4, slightly improved; 3, neither improved nor decreased; 2, slightly decreased. N1, decreased. Table shows the aggregated results. The results suggest that there is a certain effect to improve their ability on issue settings. The purpose of this study is to improve students' ability to identify issues. In order to achieve this goal, we considered a science and mathematics curriculum. In connects junior high school, and questions, research questions, and hypotheses are systematically arranged for the inquiry-based research in secondary schools. We also developed a student textbook with which teachers instruct students in setting issues. More than a certain number of students felt that their ability to identify issues had improved after taking the course.